What if I told you I could log into your account without knowing your password and you would never see it happening? Today, I'm going to show you exactly how that works using three web application vulnerability called cross-site scripting or XSS. I'm going to break through three layers of security, and at the end of this video, you are going to watch me see cookies from a web app in real time and receive them on an external server. This is not a simulation. This is running on a real vulnerable application on my current Linux machine. Everything you see here actually works. What's up, guys? Welcome back to Tech with DJ. I'm DJ, and this is where news become ninja. If you're learning cybersecurity and web application hacking from scratch, you are in the right place. I document everything I learn, break things down, and break things down simply and with quickly. If that sounds like your kind of content, hit the subscribe button, drop a like, and follow along because things are about to get interesting. Okay, before we touch anything, let me explain what cross-site scripting actually is in plain English because most tutorials get this wrong. Cross-site scripting is not about hacking the servers. The server is fine. So cross-site scripting is about injecting JavaScript into a web page so that it runs in another user's browser. Here's why that's dangerous. When you are on a website, your browser trusts that page completely. It runs whatever the JavaScript that page contains. An attacker can sneak their own JavaScript into the page. The browser has no idea. It's just cross. That JavaScript can read your cookies, log your keystroke, take screenshots, make requests on your behalf. Anything JavaScript can do, the attacker's code can do it. There are three main types of SSL or process scripting. Today, we will be covering reflected process scripting, the most common type. The payload travels in the URLs, hit the server, and bounces back in the response. So my setup is straightforward. I'm running Linux. I have DVWA, down open web application running locally. DVWA built to be hacked. It's a legal and intentional target for learning. So let me first thing I go to DVWA security. Okay, let me reset the database. Let me go down to because I told you people will be exploiting the three layers of security in this web application. So it's already set, you know, um, this is our starting point, no dependencies. We are going to end our way up to the high level. So we have the low level, the medium level, and the high level. So in this low level, there are no dependencies attached. So I navigate to process scripting reflected in the left menu. So there's a simple text box asking for my name. This text box is asking my name. Now, before I type everything, let me show you source code. So let us view the source code in DVWA. So now look at the line 3. The server takes whatever I type in the name parameter here, this particular place, and drops it directly into the HTML. No filtering, no encoding, nothing. So if I type hello, and the page says hello, but what if I type an HTML tag? So let's get to work. What if I type something like hello and submit? It brings that hello. So but what if you know I type an HTML tag, something like script, something like this, script alert, script, and hit enter, then it is a JavaScript alert box. The browser executed my code But alert, yeah, this particular number is just a proof of content. Let me show you something more meaningful. No, okay. Before we go to exploiting this thing in a proper way, this pop-up here shows that something happened, something has happened. So, but what if we try, to see a session cookie, for example, we may do something like, and here we may do something like document dot cookies and submit. Voila, it brings out, yeah, the server put my script tag directly into the HTML. The browser saw a script tag and ran it. Simple as that. So here is the lowest form. There's no defense in this low level. So we will now find our way to the medium level and try the same payload and see what will happen. Let's get to the higher, to the medium level. Stay in reflected cross script. So let's now use the same um, this thing and payload and see if it will actually work. So now there's no pop-up, there's nothing happen. It means that there is now a level of defense, attached to this one. So let us view the source code and check for, voila. So yeah, it says the place the script tag, the script, the HTML tag, the script. So because we did the script tag, it won't fire because there is a blacklist, filter attached to it. So now, but let's us now um yes, what developers think at this point, problem solved, but they've made a fundamental mistake. They are trying to blacklist input instead of encoding or output. HTML have more than 100 tags. The developer blocked one. Let me try a different approach. So we're gonna use the image tag. Since the source tag didn't work, we're gonna do something like, okay. And here is an event handler. And let's hit the submit. And it fired. Let me show you why. The 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 image, the img tag tries to load an image from the source S. That's not a real image URL. It fails immediately. When an image fails to load, the browser fires a one error event. So let me something like this. This particular image tries to load this particular tag tries to load an image from the source X. That's not a real image, but it fails immediately. And when an image fails to load, the browser fires a one error event. This one. See the one error event. I put the alert one as one error handler. Errors, fires, alert, run. The filter never saw script. I pass my payload straight through. I pass my payload straight through. So this is why blacklist don't work. You can't enumerate everywhere to run JavaScript in a browser. Yeah, so now let us go a little bit higher and let's go to the high level. DVWA. So in this high level, it is believed that there are high security measures attached, to it. So high security uses a regex pattern that's much more aggressive. It catches the script tag in any capitalization. Anywhere you try to include the script tag, it catches it. So let us now view the source code. It says replace everything that has to do with script, both X, C, R, I, and B, and T, and every other thing. It even catches script spread across multiple characters. Now, my image script tag payload say what because the regex only targets the word script. But let me show you a third technique. So if we still do something like so, if we do something like this, something like image, let us use the image payload. It will fire. The reason is that the defense on this high level only target the word script. So, but there are hundred of HTML tags to fire JavaScript code. So, but we are not going to use this one. We are going to use a third technique. So a valid HTML element. So we're gonna use the SVG tag load also alert. So we use this one. It fires immediately. The SVG tag is a valid HTML element. It supports an unload event that fires as soon as the element loads. The regex never considered SVG. So the browser uppercase SVG, that's normal. Browser behavior, that's normal browser behavior called HTML normalization. It doesn't affect execution at all. So everything up to this point has been a proof of concept. Now let me show you what a real attacker actually does with cross-site scripting. First, I will go to the website Webhook.site. This particular website. This gives me a unique URL that logs every request it receives. Think of it as my attacker tab. So we do something like we will now do. We now do everything. So we now submit it. It will trigger a get request. Now here is the full cookie value from DVWA. They restart silently in milliseconds without any visible indication on the page. The user would see nothing, no pop-up, no warning. Their browser just quietly sent their session credential to my server. This is why cross-site scripting is rated critical in all bounty program. It's not about pop-ups, it's about account takeovers. Defending against cross-site scripting is about stopping attackers from injecting malicious JavaScript into a website or web app. There are several layers of you know defense used together. So the main security measures against it include output encoding or escaping before before displaying user input in a web page. Convert dangerous characters into safe HTML entity. So the next one is input validation or sanitization. Never trust user input. Only allow expected, input. Remove dangerous tags or attributes. Content security policy (CSP). CSP tells browser what scripts are allowed to run. Sometimes HTTP only cookies. If cookies are marked HTTP only, JavaScript cannot access them. So we can also use secure frameworks, modern frameworks that helps to include process scripting risk, which are the React, the Angular, the Vue.js. These frameworks automatically escape output in many, you know, situations. But unsafe features like HTML, NHTML, and still great process scripting repetitive. Avoid dangerous JavaScript functions. So these are the few to the defense against it. So that's reflected cross scripting from zero filter to real cookie exfiltration across three security levels. In the next video, we are covering stored process scripting, and this is where it gets significantly more dangerous. Instead of the payload living in a URL, it gets saved to the database and fires automatically for every single user who visits the page. No link required. If you want to follow this full journey, subscribe to my channel. I'm documenting everything on GitHub and writing detailed breakdown on LinkedIn. Links are in the description. Drop a comment if you have questions about anything I covered today. I read every single one of them. See you in the next time, in the next one. Once more, thank you for staying with us. Um, this is our channel, Tech with TG. Subscribe and to be keep abreast with our weekly content on cybersecurity and ethical hacking events. Thank you.